Now next thing is I should write a function for addition, but before showing that I will show you something. So this read function is taking the elements from keyboard and display function is displaying on the monitor. So this read function I can implement it using extraction operator for scene, and display function I can implement it using insertion operator, that is using cout. So instead of calling them as display and read, I will convert them into operators. So I'm going to modify the code. Just watch closely. See, here is a sparse matrix class starting. So for that, again, I will explain you the class from the beginning, then I will convert those functions. See, this is a sparse matrix and these are the data members, and this is the constructor, this is the constructor, and this is the destructor. So here I will close the class. I have closed the class here. So at the end of the closing bracket, I will remove this. I will remove. So class is closing here itself. Now for implementing insertion and extraction operator, I have to follow the rule for operator overloading that is specific for insertion and extraction. First I will write insertion. I should say iStream and return by reference, and the function name is operator extraction. Then the first parameter is iStream, call by reference, I will call it as is, then comma, the sparse matrix as a parameter. So sparse matrix by reference as parameter S. Yes, this is the signature for extraction operator, that is iStream operator. It should be same, only the class name, whatever the class that you are using, you have to write down that one here. Depending on the class, this part will change, otherwise everything is same. Now for insertion operator, oStream, return by reference, and the operator name is insertion symbol, then oStream, call by reference, and I will call it as OS, reference variable name, then sparse, this also by reference. That's it. So these two functions I should implement them. So the first one is for read and second one is for display. So I will change these functions. That's it. This is for read and this is for display. Now one more thing I should do here, I should make them as friend function, because these method of implementation is done using friend functions. That's all. Now these functions I should change them as these operators, and I don't have to use scope resolution because those are friend functions. So I will write down the same signature here, copy this one, and instead of void read, I'll make it as that extraction operator. Then sparse is S. So wherever I am using the members, I should write S dot, and here S dot num, and element S dot, and this is also S dot. Then instead of display function, I should use this signature and copy it as it is here. See, that signature you have to remember it, right? Now for extraction, this S, so wherever I am accessing the members, I should use that S dot, and here S dot N, S dot element, and here also S dot element, here also S dot element. See, it was so simple. So here I am preferring to show you how to modify the code than to develop the code from the scratch. Because if you are familiar with the logic, then only thing is how to write the code. See, here already I have written one style of code, then I have modified it to another style. Now let us compile now. So that's all, it's ready. My sparse matrix class ends here. It is having constructor, destructor, and two friend functions for insertion and extraction operators, and they are friends, so they are global. So without scope resolution operator, I have written them outside. Now everything is ready. Now same thing should work. Now instead of dot read, I should say cin s1, and instead of display, I should say cout s1. Now let us compile and see if there are any errors. If anything I missed, then I get error. I will remove them. Oh, there is some error. That is, it is, yes, there is an error. See, actually, at the end of this function, I should return, because the return type of a function is return by reference of iStream. So iStream reference is is. So at the end, I should say return is. And here inside OStream, I should return OS. Let us compile and run. Yes, it's working. Now the same thing I got. Dimensions are already given, so I will give the elements only in the diagonal. So 0, comma 0 is 1, 1, comma 1 is also 1, and 2, comma 2 is 1, 3, comma 3 is 1, 4, comma 4 is also 1. Yes, I got the same output. See, there is no change in input and output, only the change is internally inside the program. The style of writing the code has changed. If you look at the main function, it looks very simple, that it looks like as if you have created an object of a sparse matrix. Then you are reading the elements using cin and displaying the elements using cout. And the whole lot of logic is there inside these functions of a class, member functions of a class. Now the next thing is I have to implement add function. So for add function also, I will implement operator. So operator overloading in C++ can be done even using member functions or using friend functions. So I will implement it using member function. So here before these friend functions, I will write on the signature for add function, that is add operator. So let us write the signature. Signature is sparse, it will return a sparse matrix, and the function name is operator plus, and this operator actually needs two sparse matrix. So one is itself because it is inside this class, and the second one is sparse. By reference, I will take S. So one parameter it will take, and one is itself. So here just after the class, I'll give a gap, and here I will implement that function. So the same function I should implement it. So I will copy this line, I'll paste it here after the class. Then just before the operator, I should use class name and scope resolution operator. Now I will implement the body of this function. So this function is supposed to add this S with itself. So one is itself, other one is S. So already we know the logic how to do. So already we know how to add two sparse matrices. I will not explain anything, simply I will type the code. Variables are declared, sparse matrix for sum, and it is created in heap. The dimension should be same m comma n comma number of non-zero elements of same matrix plus number of non-zero elements of S matrix that is coming as a parameter. One more thing, I should check first number of rows and number of columns are same, that is dimensions are same or not. If m is not equal to s dot m or n is not equal to s dot n, then return null, means it cannot be added. Otherwise, create a sparse matrix, already we have done, that is for finding sum. Now I assign, j assign, k assign 0 with a loop, I is less than number of non-zero elements and j is less than s number of non-zero elements. Check if row numbers are smaller or greater or equal. So ELE of I dot I, if it is less than s dot ELE of j dot I, then in sum dot, as it is a pointer, then I should use arrow ELE of k assign with ELE of I, and both of these should be incremented, plus plus and plus plus. Now rest I will copy paste. If this is greater than this one, then in sum copy j, that is s dot ELE of j. Else they both are equal, Then check columns. So I will copy the same code and make it for columns. This is j is greater than elements j, then copy the element of I. If this j is greater than parameters j, second matrix j, then copy the element of second matrix. Otherwise, if both are equal, then in sums element of k, copy the element of I as it is. So it will copy I, j and x also. Then x we will make it as sum of first matrix and the second matrix. So ELE of k plus plus assign ELE of I dot plus 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 dot x, and here also in sum also it should be x plus s dot element, that is second matrix, j plus plus dot x. Yes, this for loop will copy all the elements, then remaining elements we can, yes, this while loop will copy all the elements, then remaining elements will copy them by using for loops for wherever I is less than number of non-zero elements and I plus plus, then sum of element of k plus plus is assigned with element of I. Then same thing for second matrix also. Second matrix also, and this should be j less than s dot num, then this is j plus plus, and this is s dot j. Then at the end, sum number of non-zero elements must be equal to k and return some matrix. As it is called by value, so we will return the dereferenced value. So the logic is same, only the style of code is different. Just you have to watch it and observe few things, then you can write it by yourself. Now inside the main function, I will create the matrices and I will add them. So I have cleared the main function. Let us write it from the beginning. So this is the first matrix x1. The first matrix, let us say dimensions are 5 by 5 and number of non-zero elements are also 5. Then the second matrix is sparse s2, and this is also having same thing, that is number of non-zero elements are 5. Then I will say cout, enter first matrix, I will take S1, so this will enter the first matrix, then cout, I will take the second matrix, S2 will take the second matrix, then I have to find sum of these matrices, so I will say sparse sum assign S1 plus S2. This will add two matrices and the result will be in the sparse matrix sum. So addition is called and the result is obtained in sum. Now I have to print all three matrices, so I will display say first matrix NL and first matrix S1. Then cout second matrix and NL, I'll display second matrix. Then cout say sum matrix and NL, this is sum matrix. That's it. Oh, here I have done a mistake. It should be seen, I should read the first matrix and I should read second matrix and run. Yes. I have to enter the elements of first matrix, so that is I will enter diagonal elements and all the values will be 1. 0 comma 0 is 1, 1 comma 1 is also 1, 2 comma 2 is also 1, 3 comma 3 is also 1, 4 comma 4 1. Now in the second matrix elements I will enter a row element, so 0 comma 0 I will enter 5, then 0 comma 1 5, 0 comma 2 5, 0 comma 3 5, 0 comma 4 is 5. Yes, these are the elements of the first matrix that are diagonal ones, and the second matrix, first row is all 5s. Then the summation is first element is added, that was common, so it is 6, and the rest of the elements are taken as it is. The PDF for this program is given as a download, so you can download it and check it and try it on your machine, practice this program. So that's all.